Hello everyone. In this question from units and dimensions, which is basing on rotational dynamics, we are going to solve a problem. The problem says that the torque acting on a body is given by K into L plus M into I by omega, where L is the angular momentum, I is the moment of inertia, omega is the angular speed. I don't know anything about K and M, but we want to calculate what is the value of the dimensions of that K and M is. That's a problem that we are trying to solve now. Anyway, let me write the equation that he has given. It has given that torque is K and L, where L is the angular momentum, M nothing mentioned, I we know moment of inertia, by omega angular velocity. Anyway, when we say torque is sum of these two physical quantities, this must be equal to torque and this also must be equal to torque, because we can get a torque only when we add two torques. That's called principle of homogeneity. We can add only physical quantities of similar nature. That implies it is clear that KL as well as Mi by omega has dimensions of torque. They are dimensionally same. Taking that basic observation, let us write the dimension formulas of things that we know. Torque. We know torque is mathematically defined as product of force and perpendicular distance, R bar cross F bar, or in terms of just a dimensional formula I can write F into R. I know F is nothing but MA, R is nothing but L. So dimension formula of the torque is nothing but ml square t power minus 2. And L is called angular momentum. Angular momentum is nothing but moment of momentum. Moment of means R of, distance of. Momentum is nothing but equal to mv. So it has a simple formula of mvr. It has a dimension of m. V is nothing but Lt power minus 1. L, R is nothing but equal to L. So this is also having a similar dimension formula. Not similar, exactly similar. M and L square is same, but time power is minus 1. That's how the time powers are different here. Now let us use a concept like torque has same dimensions of KL. I know K, I know torque and I know L. Then I can write the dimensions of K as torque by L. L is angular momentum. Torque has the dimensions of M, L square, t power minus 2. Angular momentum has the dimensions of mvr, m L t power minus 1 and L. Therefore, ml square t power minus 1. If you simplify, I will get simply t power minus 2 and t power plus 1 is nothing but equal to t power minus 1. All other terms were already cancelled. So now I know the dimensions of K. Let us similarly try to solve the next part of problem. Again, M I don't know, but it is given that I is called moment of inertia. Moment of inertia has a mathematical form of sigma mr square or mk square. In terms of dimension, simply m, r is nothing but equal to L square. We also have angular velocity here, omega, angular velocity omega, which is defined as d theta by dt. D theta is the angle that won't have any dimension. So by time is only having dimension t power minus 1. Again, equating the torque to the second part of the equation, torque equal to m into I by omega. I know the dimensions of torque already as ml square t power minus 2. M I don't know, I have to calculate. I is nothing but equal to ml square. Omega is nothing but t power minus 1. So I can calculate the dimensions of this m, that's what's this is not a mass, this is m that we want to calculate, that one. M equal to ml square t power minus 2 into t power minus 1 by ml square. So ml square will cancel. M has the dimensions of t power minus 3. Now I know the dimensions of k, I know the dimensions of m. I need to know the dimensions of k and m. So dimensions of k and m is t power minus 1 into t power minus 3, that's nothing but equal to t power minus 4. Thus we can conclude that the km, the dimension formula that what we need to calculate, has the dimensions of, there is no m, that means mass power dimension, there is no L power dimension, but the time has a dimension of power minus 4. Thank you for staying by. There are so many further lessons in the website venkatacademy.com, and in this YouTube channel also there is an entire physics course to go through. Thank you and welcome to this learning method. Right? Thank you.